Hello, welcome back to Chapter 5, Section 6, Slope-Intercept Form. This is the final problem in the guided practice set of problems. It's on page 338. The PDF is page 47, and it's problem number 12. Very similar to the problems you're going to be doing for the homework. So I'm going to read the problem. Excuse me. Helen's in a bicycle race. She's already biked 10 miles, and she's now biking at a rate of 18 miles per hour. So her rate is now constant. They're throwing some calculus at you, but don't worry about that. Her distance as a function of time is shown in the graph. So let's talk about the graph. Time is the number of hours that she's been biking. 1 hour, 2 hours, 3 hours, 4 hours. Okay? So this is a pretty big bike race, all right? This time right here is my independent variable. So I'm going to have x represent time measured in hours. Now, I could also use t for time, but as I mentioned in the previous videos, if I was going to switch over to like technology, Desmos, graphing calculator, it's not going to know what I mean by t. So that's why we need to be able to use it as an x. But if we're not using that, t is perfectly legitimate. There's nothing wrong with that. And maybe I might even write that with this one. Okay? Along this axis, this is my dependent variable. And this is going to be my y. So my y is going to represent distance measured in miles. All right, so what I have here, I'm going to let x represent time in hours, and I'm going to let y represent distance. How far she travels is how long, if she's at a constant speed, and I'm getting ahead of myself, but if she's at a constant speed, how far she travels is a function of how long she's been biking, miles. All right, so I know that my slope-intercept form, I'm going to put it up here. I probably have it in my notes somewhere. I know that my slope-intercept form is y equals mx plus b. And remember, only the x and the y, which in this problem are time and distance, those are the only variables. The m and the b are parameters, not variables. They're going to be different for a different bike rider. A different bike rider is either going to be going faster or slower. Okay, so they're going to be going at a different rate of speed. They may also have started their constant part at a different place instead of at the 10 miles. Okay, but the m and the b get confused with variables because they're letters. That's not what a variable is. All right, a variable is not a letter that stands for a number. A variable is a measurement that can change. At this point, she is biking at a constant speed of 10 miles per hour. And when we've started, she's already started a bike 10 miles. Those are not going to change in this problem. So they are constants. So we got to figure out which one's the slope and which one's the y-intercept. Remember that the slope in the story problems, look for the word per, because that tells me the rate of change. So I'm looking for the word per right there. So 18 miles per hour tells me my slope, 18 miles per hour. The y-intercept is where you started when time equals 0. Now this is a little confusing because it says she's already biked 10 miles, right? That's why I said this is kind of a calculus problem, because at first you don't really start off at, you don't start instantaneously at 18 miles per hour. So she's already biked for 10 miles. Her speed has been different, which becomes like a different type of a problem. Again, calculus. We're just saying that when we start her time, she's already been biking, and she's already been biking for 10 miles. So the y-intercept, where she's going to start, or where we're going to start keeping track of her, is at 10 miles. All right? So to write the equation represents the distance for part A, it's going to be y, her distance, is going to be 18 miles multiplied by every hour that she's going to bike, plus the 10 miles that she already started. Identify the slope and the y-intercept. Well, I guess I've kind of been talking about it. 18 is the slope. This is 18 miles per hour. So in other words, it's how fast she's going. That's her speed. The 10 represents the distance that she's traveled when the time equals 0. In other words, when we started it. Which again, for this problem, doesn't really make sense, because why didn't you start like when she started? But we're only looking at the straight line portion of this, right? Finally, for the last question, I'll move that up so you can see it. How far will Helen have biked after 2 hours? Hopefully I got some room in here. So I do y equals 18 after 2 hours plus 10. 18 times 2 is 36. 36 plus 10 equals 46. So her distance is going to be 46 miles. And I know I did that in my head. You want to do a calculator? We'll do 18 times 2 plus 10, and I get 46. All right. Good luck with that. Ask questions in the discussion, and good luck with the homework. Bye.